Hello everyone, my name is Phillip. I'm a Master of Applied Science student on the supervision of Professor Steve Mann at the University of Toronto. The paper I am presenting today is titled High Dynamic Range HDR Signal Processing on Software-Defined Radio. This work increases the dynamic range of software-defined radios, SDRs, beyond their hardware system limitations by using multiple SDRs. Figure 1 illustrates that in this work, two SDRs are connected to the same antenna to receive the exact same low dynamic range LDR signal at differing gains, one at a high gain and one at a low gain, which is then digitally processed using signal compositing in order to get the high dynamic range HDR signal. The HDR algorithm used is shown below. The equation essentially uses the two-channel input, FIN, one channel from each SDR, and combines them into a single output HDRN. The variable n represents the timestamp of a particular sampled data. The function of CI represents the certainty function used for signal reconstruction. Certainty function is dependent on the characteristics of the acquisition system and asserts how accurate a measured signal value is compared to the input. The experimental setup is shown in figure 2. We chose HackerRefs as our SDR of choice. A HackerRef is used for transmitting a signal. The two HackerRefs are connected to the same antenna through a power splitter in order to receive the same signal. Note that here, a negative 9 dB attenuator is connected to one of the SDRs for the low gain. The SDR without the attenuator, 0 dB, is the high gain SDR. All the three SDRs are connected to a PC for data acquisition and logging. The sampling time between the SDRs is synchronized using the GPIO pins on the SDR's internal CPLD. Note also that the HackerRefs are clock synchronized. The results in figure 3A show that the 0 dB SDR blue line exceeds the dynamic range of the system and clips, while the negative 9 dB in the green line obtains a clean signal. The HDR signal in red is not clipped when compared to the highest gain signal from the 0 dB SDR. In figure 3B, the negative 9 dB SDR in green is shown to have quantization noise, while the 0 dB receiver blue is smooth. The HDR signal in red is less noisy when compared to the lowest gain signal from the negative 9 dB receiver. The HDR technique is used to enhance the dynamic range of the SDRs, and in conclusion, the results show that the dynamic range does increase beyond the limitations of a single SDR from 48 dB to 93.6